right, well, welcome everyone to Supplemental Heat and Dual Fuel Options in Heat Pumps. This course is approved among many different CEUs, as well as a lead accredited professional in homes for this particular course. And as always, AIA, Health, Welfare, and Safety, which may make it applicable to your state-based design or contractor license. Today, I will be your moderator. My name is Brett Little, and I'm here with the nonprofit, the Green Home Institute. Our top tier sponsor for this session, a huge thanks to them, Mitsubishi Electric, taking new multifamily, single family, new and renovations to all electric heat pump technology that works in the coldest of cold weather, helping you get to net zero as well. Check out everything they got going on at Mitsubishi Comfort as well. And then also I'm excited to have one of our other sponsors talk about something new that they're doing on live today. So I'm going to quick hand it off to him before we get started. Ty, you with us?
Yes, I am. And I'm just kind of old and slow here getting things going, but thank you very much for a minute at a time. Thank you, Mike. And I'm sure everybody will enjoy the webinar of Mitsubishi. We've got a nice 1-ton ducted mini purring away in our lab here, undergoing some testing, thanks to Mike and all the cooperation from Mitsubishi with our efforts. Anyhow, I'm Ty Newell with Build Equinox, and we're the manufacturers, the developers of what we call the Serve-2 smart ventilation system. And it's among our activities to basically learn how we live on a piece of land without spoiling it. But among other things, as Brett mentioned, how do we sustainably live in a healthy, comfortable manner, live on our daily allowance of solar energy? So that's what we're about. We're in the middle of Illinois, and what I just want to mention is a new announcement that we're very excited about, and it seems very contemporary with today's pandemic raging on around us, but this is something that's been in the works for the last 2 to 3 years as we introduce our second generation Serve unit. And what we just announced in our most recent newsletter is what we call Serve UV, an ultraviolet air purification system that integrates into the Serve. The Serve was designed for this integration, but it takes about 2 years of testing before you know that you're not going to destroy your machine, as well as that it's effectively operating. And so this ultraviolet sanitation produces about 0.02 watts of ultraviolet radiation that has per CFM of airflow, about an 85% kill efficiency for our 200 CFM nominal airflow operation. And with the aluminum ducts and heat exchangers that the Serve is designed around, these act as reflection chambers that further enhance its coverage and kill efficiency of viruses. It also sanitizes the heat exchanger and drain pan, and the 18-watt bulb usage is equivalent to about 5 cents of operational cost per day with continuous operation. And just coincidentally, if you want to learn more, we're very active on the latest on COVID-19. We do our own predictions of where this virus is going. And it just happens that today at 2 p.m. Eastern time that we are having a COVID-19 webinar. So join us if you would like to learn the latest, as well as why this current surge is happening. And for those of you HVAC professionals and interested persons, it is inadequate airflow, inadequate filtration, inadequate air sanitation that's a large factor in today's current surge. So thank you very much, Brett, for the time.
Yeah, thank you, Ty. Everyone, check that out if you get an opportunity. We hope you can make it. So with that, I am going to introduce today's speaker and hand it off to him, Mike Schaefer, Regional Sales Manager, Mitsubishi Electric Train HVAC US LLC. Mike has been in the HVAC industry since 2005, where he has worked on all levels, including contracting, distribution, and manufacturing. Mike joined Mitsubishi Electric in 2014 and has held multiple roles, including commercial area manager, residential area manager, and was most recently part of Mitsubishi Electric's performance construction team, which is focused on providing healthy, efficient, and reliable mechanical solutions to high performance building market. He is currently the regional sales manager for the Chicago market. And with that, I will turn it over to Mike and take it away.
All right, let me grab the screen. Thank you, Brett, and thank you, Ty, for the great introduction on the new product there from Build Equinox. They're a great partner of ours. I love working with them as well too. Let me make sure. There we go. I wanted to leave my camera on just to say hi so you can see me, but I keep getting warnings that the internet connection is not great and I need to turn my camera off. So I'm going to turn it off while I'm doing the webinar, and then we'll kick it back on when we're doing Q&A after. But I at least wanted to see everyone and say hello before I kick the camera off here. And then we will get started. So this is our third webinar that we've done with the Green Home Institute since we become a partner. So we did one on VRF, we did one on fully ducted air source heat pumps, and then now we're looking at, okay, what's the next step? And the next step we've seen here in the Midwest is, what about supplemental heat? And in the colder climates, and possible dual fuel options for these cold climate air source heat pumps. So that's what we're going to talk about today. I'll go through the learning objectives here in a second. I want to make sure my slides are all advancing appropriately. Okay, we're good. So what we're going to talk about today then is cold climate air source heat pump technology, electric and dual fuel backup heating applications, and control strategies to optimize system performance. There we go. Learning objectives: articulate cold climate air source heat pump technology. If you were on some of the previous webinars that I did, this will be a little bit of a recap, as well as the next bullet point, which is review indoor unit options and applications. However, if we don't recap that, then we're not going to have the background information we need to get to the next bullet point. So if you're on some previous webinars, there's going to be some review. And if this is your first one learning about the air source heat pumps, then you're going to get some new knowledge at the beginning as well. Then we're going to talk about the types of backup and supplemental heat, electric as well as gas or propane options, and then the control strategies for third-party supplemental heat. And all these things are going to tie back into some lead bullet points that Brett will address as well. So first, starting off, what is VRF technology and what are the benefits? So the first question we always got to lean to is, well, what is VRF technology? So VRF technology is variable refrigerant flow technology. In essence, in its simplest forms, VRF moves refrigerant instead of air. The efficiencies and the benefits you get is that I am moving refrigerant, just break it down to cold or hot, through a home or a business or a building, instead of having to move air throughout everything. So it gives us a lot of benefits, which we will talk to, but in essence, VRF moves refrigerant and not air. The heart of our system is the compressor. So when we talk about what a big difference is VRF versus traditional heating and cooling systems, it ties back to the compressor. A traditional compressor system maintains temperatures by turning on and off dependent upon set point. This means that they're constantly ramping up and down in order to keep the temperature. They're drawing a maximum energy input each time the system starts. So you get these big energy spikes. When the system turns off, the set point temperature naturally drifts and it's no longer maintained, it's no longer comfortable. Traditional compressor systems also employ a constant fan speed to deliver comfort to the entire zone, right? The entire home. When the system reaches the set point, the fan then inevitably just shuts off. So that's where you have these set point drifts as well as these energy spikes. An inverter-driven system is completely different. Upon starting, inverter compressors ramp up speeds to beyond traditional systems, in order to rapidly bring the temperature down to the desired set point. So it brings that desired set point temperature down quickly. Once the set point temperature is reached, the fan rotation speed is maintained at low levels. So this just maintains a consistent energy usage as well as a consistent temperature to avoid those drifts in energy consumption spikes. Think of inverter-driven compressors as similar to cruise control in an automobile. How you press the gas pedal to reach the speed limit, then you set your cruise control. Same thing here. We're going to press that gas pedal, we're going to reach our set point, and then we're going to hit the cruise control and just let that inverter compressor do its job. So what are the benefits of an inverter compressor? Temperature set point is reached faster, comfortable indoor climate consistently maintained. We eliminate those power spikes, right? If you're used to an old traditional air conditioner, you may see the dimming of lights when it kicks on. You hear the big rumble when it turns on. We eliminate those things. Generates greater heating performance, which we'll talk to. And then energy is used more effectively, right? Systems last longer because there's less wear and tear on that compressor than there is on that traditional on-off compressor. So now, since we're here in the Midwest, I'm based out of Chicago. Brett's based out of Grand Rapids. We're here talking about Midwest climate. So what about cold climate heat pump technology? How does that work? So if we look at a traditional air source heat pump first, they've been around for a very long time. So traditional air source heat pumps are not new. They've been around for decades. People have used them to varying success over time. Historically, they've only been used as primary heating in warmer climates, or supplemental or shoulder season heating here in the Midwestern and colder climates. As we can see from this chart, so this is looking at a traditional air source pump, as the temperature begins to fall, the traditional heat pump loses its ability to provide sufficient heat. Traditional heat pumps, whether they are VRF heat pumps or not, should not be used as a primary heat source here in cold climates. So as we can see in this traditional heat pump, as we start to get down to around freezing temperatures, we drop off significantly. And that's the same for VRF or traditional heat pumps that are not cold climate heat pumps. Would I feel comfortable putting this unit in my home if I'm only getting, say, 20% capacity at -5? Not here in Chicago. I definitely would not feel comfortable. But this is how a traditional air source heat pump works, where here in the Midwest, it's used more as supplemental heating or shoulder season heating. Now, if we look at a cold climate air source heat pump, they provide outstanding heating performance even in the extreme cold. Cold climate heat pumps maintain 100% heating capacity down into the single digits. They do not begin to lose capacity as it gets colder outside. However, the D rate, I'm sorry, I misspoke there. They do begin to lose capacity as it gets colder outside. However, the D rate's much less, and they continue to maintain very high levels of heating capability in sub-zero temperatures. As you can see from this chart here, you're maintaining 100% of your heating capacity down to 5 degrees. And only at that point do you start to lose your heating capacity. But it's a much slower D rate. This chart's showing about 80% capacity at -13. We want to dig in a little bit deeper. Let's take a look at the heating capability of a 2-ton traditional VRF air source heat pump. So this is a VRF system. It has the inverter compressor, but it's a traditional heat pump, not a cold climate system. As we can see, this heat pump's ability to provide sufficient heat begins to drop off once we get below freezing. I certainly wouldn't want to have this as a primary heat source in my home here in Chicago, right? Would this be okay if I lived in Dallas, Texas? Yes. Is this okay if I live in Detroit, Michigan? No. I am actually derating enough that here at 5 degrees, I'm giving approximately about 53% of my heating capacity. That's okay for supplemental or shoulder season heating here in the Midwest, but not as a primary source of heat. Now let's take a look at the heating capability of a 2-ton VRF cold climate air source heat pump. This heat pump maintains 100% of its heating capacity down to 5 degrees and still maintains about 90% of its heating capacity at -13. Please note these are all ambient temperatures, as wind chill has no effect on the heat pump's performance. So this is -13 ambient air temperature. It may be -40 wind chill for all I know at -13, but this is only looking at ambient air temperature. What happens if it gets colder than -13? The heat pump will continue to operate just at a lower capacity. So we're going to see that D rate continue on beyond -13. I personally would be 100% comfortable installing this cold climate heat pump as my primary heating source here in Chicago. -13, I'm getting 90% of my heating capacity. As long as I sized my system appropriately, I would feel comfortable with this as my primary heat source here. So what makes up a VRF heat pump system, and what are some different indoor unit options and applications? Now that we know the difference between a traditional heat pump and a cold climate heat pump, what kind of makes up that system? A basic single zone VRF air source heat pump, which we can see right here on the middle of the screen, has an outdoor unit and an indoor unit. The outdoor unit powers the indoor unit, and refrigerant and communication lines connect the two components. The indoor can be controlled via handheld controller, wall mount thermostat, or Wi-Fi controller, many different controls options, but there needs to be a controller to actually control that system. A multi-zone VRF system, which we can see over here on the right hand of the screen, has an outdoor unit that can connect to multiple different indoor units. The outdoor unit powers each individual indoor unit, and refrigerant and communication lines connect all of the components. Multi-zone systems enable a home or building to have individual temperature control and zoning for each space that an indoor unit serves. Each indoor unit is controlled either separately via individual controllers or can be grouped together to act as a single zone. So we see the system here on the right. This is showing that I can connect 7 indoor units on this system. Most multi-zone VRF systems can have as few as 2. You always have to have 2 indoor units connected on a multi-zone to as many as 8 from a residential standpoint. So you can connect multiple different indoor units to this one outdoor unit. They do not have total independent control, meaning I can't have one zone in heating with one zone in cooling, not on the residential system. On commercial systems, we can do that utilizing heat recovery. But on residential systems, I have individual temperature control, but not mode control. Meaning I can have them all set at different temperatures, but I can't have some in heating and some in cooling. There's some ways around that with some controls options, but in general, when we speak about it, these are not heat recovery systems in residential applications. They can't do simultaneous heating. Indoor units. So indoor units come in a variety of designs to fit various applications. The different indoor unit models can be installed in a single zone application or mixed and matched in a multi-zone application. So this first one here we're seeing is our horizontal ducted unit. It's showing just a register here. I guess there's a unit behind there. You can guess if there's one or not, but the picture's nice. That unit would be similar to this horizontal ducted system right here that's below this outbuilding. That's what you would see behind this wall here. So that's a horizontal ducted system. And we also have ceiling recessed. Those come in one-way ceiling cassettes that you can see in this picture, and then there's also 4-way ceiling cassette options, but these are ductless units that mount recessed into the ceiling. And there's floor-mounted options as well. So this is a ductless unit that is mounted low to the wall. So it can go on the floor, but it's mainly mounted as a low wall mount. We use these traditionally in applications where you don't have high wall space. We do it a lot around Chicago, where you think of a Chicago bungalow where they finish that attic space into an additional bedroom, and you just don't have high wall. You got vaulted ceilings and knee walls. A floor mounted system is perfect where you don't have ceiling height. Then you have wall mounted units where there is a multitude of different options and styles of wall mount units. But this is by far the most popular system that we have. It's ductless and it mounts directly on the wall. So it's providing the heating and cooling right into the space that it serves. And then our last option would be a multi-position air handler. So this is very, very traditional when we look at an indoor unit. This is what someone is used to when they think of a furnace or an air handler. We have that. It's a multi-position air handler. So we'll dig into the supplemental heating options that tie into this a lot when we get into that portion of the presentation. I did want to take a minute though and dig in a little bit deeper on the ducted indoor units, mainly because when people think of VRF technology, they primarily think of ductless wall mounts, and these ducted indoor units get overlooked a lot. So there's a lot of applications where you can use these, and we'll look at that when we get into applications, but I want to just dig a little bit deeper into each different style. So there's 3 basic types of ducted indoor units. First, here we have the horizontal ducted indoor unit. This is a low static air handler, meaning it's not built to move a lot of air. It can if it's designed correctly. It just has very low external static pressure and lower CFM. So it's really designed for a limited amount of ductwork. You can put more ductwork on here. You just have to make sure you're doing a really efficient duct design on it. This unit is extremely quiet, very small footprint, great for serving 1 or 2 rooms, something where you need a really compact design. You're putting a unit above a drop ceiling or above a in a tight attic space, something where you don't want to see a ductless unit or you're trying to pick up multiple real small zones. This is a great fit for that. Next is a medium static horizontal ducted indoor unit. This air handler has a higher external static pressure and higher CFM, which enables much more ductwork to be attached in the low static unit. This unit's also very quiet, still maintains a small footprint. It's slightly larger than the low static unit, but it still maintains that horizontal footprint. So this is great for ducting whole floors, apartments, small homes. You can get a lot more done, a lot more ductwork on this medium static unit. Lastly, we have the fully ducted multi-position air handler. This unit has high external static pressure and is very similar to a traditional forced air furnace or air handler. It's extremely quiet as well, like all of these indoor units are. Now, what you'd expect from a fully ducted air handler, much quieter than even a high efficient furnace or a high efficient traditional unitary air handler. Multi-positional, they have upflow, downflow, horizontal left and right. Air handler is great for ducting whole homes, apartments, and can be retrofitted into existing duct systems. That's the big benefit to this unit, is it's very, very traditional. So whether it's new construction and the homeowner wants or the builder wants a traditional look, or this is retrofit where you already have an existing duct system, you can retrofit this right into it. So it's a very, very traditional look and feel, but it's a well-built air handler. Much quieter and efficient and well-built than what you would expect from it. Now that we know the different system and indoor unit options, what are some common applications that we would tie this equipment into? The #1 application for ductless equipment in the US is a single zone system for the master bedroom. The single zone solution is great to take care of any room that's hard to heat or cool or has different usage from the rest of the home. So if we're looking at a traditional home, we're going to look at this footprint here when we talk about applications and different system design. If we're looking at a single zone, the most popular by a long shot is the master. Why is the master generally the most common application for a single zone? In most builds, the master is usually, if it's a 2-story, it's on the 2nd floor, maybe partially over a garage. If it's a ranch, it might be the furthest away from the furnace, furthest away from the air handler, so it's on the longest duct run. It's getting the worst amount of airflow, and it's where the owners of the home spend the most amount of time. So this is the room that if it's uncomfortable, it's the one that people really want to take care of. So a single zone application is really prevalent in master suites. What we've seen a lot during COVID-19 is another front runner coming for the most popular single zone application, which would be the home office. Now that people were having to spend a whole lot more time in their home and creating home offices or spending more time in their home office, they're noticing that that room as well is very uncomfortable. It also goes back to the concept of why am I heating and cooling my entire home to a specific temperature if I'm spending all of my time in the home office or the master suite, right? Let's take care of that room that you're spending the most amount of time in. That's your single zone application. Those are the most popular for that. What about multi-zone applications? So speaking of hot and cold rooms, most homes have more than one trouble spot. We said home office, master. In this application, bedroom 2, bedroom 3. For a home like this that needs individual control in more than one space, a multi-zone system is a great solution. The existing home system can stay in place. So let's say you have an existing furnace and air conditioner that can stay there, and the multi-zone system can be installed to handle these specific zones. It's not always hot and cold rooms. It can also be important rooms, right? A home office may not be uncomfortable, but it's important. A nursery may not necessarily be uncomfortable, but it's very important that we keep it comfortable. So it's not only hot or cold spots, it's also usage of a home. Are there specific zones that need to be addressed differently than the rest of the home? A multi-zone application is great for picking up multiple trouble spots. Over the last few years, due to the expansion of the cold climate heat pumps that we looked at, the different array of indoor units, whole home design is actually becoming much more prevalent now with this equipment. Whether the system or systems are for heating, cooling, or both, mini multi-split heat pumps can handle the entire home. This design shows 2-zone fully ducted solution. So what we're looking at here is 2-zone, multi-zone, fully ducted option. But there's numerous ways to design with these systems. We're going to look at a couple options. This is one. There are a multitude of different ways. Desired zones, load profile, the heating source you're using, other factors will determine the overall system design, but you can utilize multitude of different ways to actually attack this whole home design. This one here is looking at a 2-zone fully ducted solution. You could do this with multi-zone ductless solutions. You could do it with a mixed ducted ductless application. There's a lot of different ways to even address this simple home plan. It really ties into what does the homeowner need and what does the homeowner want. I get plans a lot from builders and contractors that say, what Mitsubishi system would you design for this house? There's a list of questions we need to ask first, right? How many zones do we need? Do they want ductless? Can we install ductwork on here? Is there a supplemental heating source that just helps determine what we're trying to design for? Do they need individual control in certain spaces? There's a lot of questions that need to be asked because we have a lot of different options. So we want to make sure we ask those questions appropriately instead of looking at it and say, okay, I see this plan. I need 1, 2, 3, 4, 5 zones in here. Not really. Here's another example of a whole home design that's much more traditional. If the homeowner desires an all-electric heating and cooling solution, but wants a traditional furnace and air conditioner feel, a single zone, fully ducted air handler solution would be perfect. This system incorporates perfectly with electric resistance heat kits if supplemental heat's required, which we're gonna talk through here coming up right next. So speaking of supplemental heat, now we're gonna look at many different types of electric and gas options that are available. But when do we need backup or supplemental heat? Climate is the #1 reason. While cold climate heat pumps have tremendous heat output, even at sub-zero temperatures, as we saw in the earlier slides, there are climates where it gets too cold for heat pumps to be a sole source of heat, no matter how good we are as a cold climate heat pump. Think about Minnesota, Wisconsin, Northern Michigan, the Dakotas, and others. Backup heat is needed in these areas. It's just required. It gets too cold. Larger heating BTU loads may also require supplemental heat to help make up extra BTUs that the heat pump cannot produce. Think of larger homes that need more heating capacity. Just speaking to Mitsubishi, our largest multi-zone cold climate residential heat pump is 4 tons. So that produces 54,000 BTUs of heat. That may not be enough heating for larger homes that need a higher capacity. Maybe some supplemental heat can make up those extra BTUs. Lastly, if there's already a heating source in place, like a boiler, and an air source heat pump is being installed primarily as a cooling solution, it makes sense to utilize both heating systems at optimum times for energy savings and comfort benefits. So if you already have a good heating source in place and you're installing a air source heat pump primarily for cooling, let's utilize both here and get the most efficient and comfortable option. Let's look at electric backup heating options first. The most common that we're going to integrate into our systems is electric resistance heat kits. So electric resistance heat kits can be installed directly onto a fully ducted air handler, used for emergency backup heat or to make up supplemental heating BTUs on extremely cold days, if needed, right? Climate, where are you at? What's your design temp? Those are the things that we're going to need to look at. They run run in conjunction with the cold climate heat pump and can be engaged based on outdoor air temp or a drop in indoor space temp. They can be single stage or dual stage heat kits as well. So an important thing to remember with backup electric heat on an air source heat pump is that it's not necessarily one or the other, right? Especially with these heat kits that go on the multi-position air handler. If that cold climate heat pump can't keep up and it needs to engage a backup heat source, these electric resistance heat kits will engage and the air source heat pump will continue to operate as well. It will just work to make up those supplemental BTUs if that's the way you need it. You can also tie in third-party electric duct heaters to ducted indoor units. Here's an example of inline electric duct heaters. So think about these going on those horizontal ducted units. Here's actually a picture of one of these being integrated into a horizontal ducted unit. Inline electric duct heaters can be installed in the ductwork of a horizontal ducted air handler or a fully ducted air handler. They can work on the fully ducted systems as well too. Same concept and application as these electric resistance heat kits. They can be on off, they can be modulating. These are third party. Mitsubishi does not make these or resell these third party heaters, but we have a lot of people that we work with. So we can tie into those. We'll talk how we can integrate those from a control standpoint, but this could work if you're utilizing primarily one of those horizontal ducted units and you want to incorporate some backup heat onto those. These inline duct heaters work. What if there's no ductwork in the home? It's pretty easy to integrate the electric heat backup when you have ductwork in the home, but what if you don't? What type of backup can be used? The most common and ductless applications for a backup from an electric standpoint is electric base heaters. There's a lot of options, but electric baseboard heaters is primarily the most common. They're very cost effective in terms of upfront cost. Electric resistance heat, we all know, uses a lot of energy. So they're not the most efficient to run. However, they're very simple to install. They're easy to operate, and it's a very low upfront cost for electric baseboard heaters. Electric wall heaters and electric fireplaces are another option. We use the electric wall heaters a lot in multifamily applications. Once again, they're very simple. You can just put one in the common living area in the main living space, and it's an emergency backup if it needs to be turned on. A lot of times they're just manually operated. We use them in multifamily applications a lot for hallways or just common areas. An emergency backup source, or to keep stairwells in multifamily applications just up to temp, maybe 50 degrees, just above freezing since no one's living in that space. Electric fireplaces, you start to think of how am I going to put backup heat in an area where I'm all ductless? Well, an electric fireplace. There you go. There's your emergency backup. It's there if you need it in an emergency application, and it's nice to look at. It's nice to have a fireplace in the space as well. So an electric fireplace is a really good option. A less common but viable option is an electric boiler. This can take care of domestic hot water needs and can also be used for backup space heating. We don't see a lot of electric boilers, but it is an option that we can use. Only issue with an electric boiler is the higher operating cost, obviously, is when in regards to energy consumption. An electric boiler is going to cost a lot more to operate than a natural gas boiler, but it is an option if you're utilizing an all-electric home. Lastly, electric warm floor systems are very popular for backup heat in smaller spaces like bathrooms or kitchen. So let's say we're looking at a home design and we don't have direct space conditioning going into the bathroom, which is very common, especially if it's an interior space. Putting a little bit of electric warm board or electric in-floor underneath the flooring for that bathroom or for the kitchen really helps from a comfort standpoint. It's not really a backup emergency type system because it's not throughout the entire house, but it's really great for comfort in bathrooms or kitchen areas. A lot of times where you have tile flooring. What about dual fuel systems? Let's start talking about dual fuel applications. Gas integration is a top priority for Mitsubishi Electric and other manufacturers. And there's a lot of great products and solutions that we will see in the next year or so. We got a lot of things coming. It's high priority for us. We know that it's a great bridge product going from natural gas homes to all electric. Dual fuel is a great bridge opportunity. We have a lot of things coming. We see the potential for dual fuel as this bridge solution, especially in the gas-driven Midwest, to electrification. So it's the bridge solution to electrification. We know that. So we need to have that product to ease people over there. By integrating cold climate heat pumps with gas burning HVAC systems, we can drastically lower fossil fuel usage while our grids are becoming cleaner. So that's the big thing, is getting people over to electric heating solutions while our grids are becoming more based off of renewables, solar, wind, hydro generated grids. While those are becoming cleaner, we can use this as a bridge solution. Our current solution that's becoming more common though, even with our existing equipment, is the use of hot water coils on fully ducted air handlers as a secondary heat source. This allows the use of a gas boiler for domestic hot water and secondary space heating when tied with an air source heat pump. The hot water coil would be a third-party source product, sized appropriately for the heating need and CFM static requirements of the area. So the coil itself would be a third-party source product that you would tie into the boiler system you already have, and then that can tie and be controlled by the air source heat pump. So think of the air source heat pump acting as first stage, and the hot water coil then acting as second stage heat or acting as an emergency backup. So while we don't necessarily have the dual fuel product fully in-house right now, this is something that we can do any day. This picture that you're seeing right here is actually from a contractor in Southern Indiana that does this a lot. So he actually utilizes a single stage air source heat pump with this fully ducted solution, and then ties in this third-party hot water coil as second stage heat or backup heat. So this is an application we can do now, and it's growing in popularity as well. If you already have a whole home primary heating source like a boiler, you can utilize an air source heat pump for cooling and as a secondary source of heat. Depending on the age and condition of the boiler, you may want the air source heat pump to be the main source of heat and only utilize the old boiler system as an emergency backup. So think of some existing homes that have very, very old boiler systems or very old piping systems or failing piping systems. It wouldn't necessarily make sense to repipe the entire house, but if that is a functioning system, maybe leave it and utilize that as an emergency backup with a cold climate air source heat pump. The application would depend on whether the heat pump system is sized for cooling or primary heating. By combining two systems like this, you get the high efficiencies of zoning of the air source heat pump, along with the comfort and high heating capacities of radiant or in-floor boiler heat. You can also control how and when each system will turn on or off. The next section we speak to how to control these supplemental heating sources we just mentioned. We're going to talk about how to actually engage these supplemental heating sources. But first, I want to show you what type of systems are actually out there. So control strategies for third-party supplemental heat. I don't know if I wanted to take a second, and Brett, if we had any questions or anything, it's a good place probably to take a minute, or we can just address anything at the end if we don't have anything pertinent right now.
Yeah, we can wait till the end. Thanks.
Perfect, thank you. Plus it gives me time to get a drink of water. All right. Electric resistance heat kits. So how do we engage these? Electric resistant heat kits that are built to work with the fully ducted air handlers are the most popular method and easiest to control. Most systems will engage these backup heat kits via an outdoor temperature sensor or drop in indoor space temperature. The air source heat pump will continue to run, but will engage the heat kit to supplement any BTU loss at either a desired outdoor air temp or when the space temp drops below, say, about 2.7 degrees. Some of these things I'm going to speak to are Mitsubishi specific, just because I don't know what everyone else's other manufacturers have in terms of requirements. Standard system controls, such as wireless and wired wall controllers or Wi-Fi enabled app-based controllers, can easily adjust these temperature differentials. Please refer to specific manufacturer specs for what these temperature differentials are. This is a very popular backup heat strategy due to the simplicity of controls and ease of installation. I always say, And if anyone is on here that I work with design applications on, I don't see the attendee list, but if there's anyone on here that I currently work with, you can attest to this. If you are putting in a fully ducted air handler solution in the Midwest, just put electric resistance heat kit on it. It doesn't hurt, right? For the cost to add on a simple piece like this, the control strategy is so simple, especially if it's the same manufacturer. So if you're putting a Mitsubishi air handler in, you're putting in the Mitsubishi heat kit, they integrate seamlessly together. It's worth putting it on just for the peace of mind of an emergency backup solution, even if you don't necessarily need it. So if you're sized appropriately, the load's low enough, you don't really need supplemental heat. If you're putting in the air handler, put a heat kit in. It's simple enough to do. I would 100% do it in my home if I was putting in that application. It just makes sense to do it because it's so easy to integrate. So if you're dealing with a fully ducted air handler, the electric heat kit is really, really simple on how to control it. Absolutely easy to do it. Be an outdoor air temperature or drop in space temp. It's very, very simple to do. You can accomplish the same thing with the third-party inline electric duct heaters on the horizontal ducted indoor units. In this instance, the duct heater is installed in the supply air duct and is energized by the auxiliary terminal on the indoor unit. The dry contact closes when the desired indoor space temperature drop is reached. These heaters are built as a not run unless the indoor unit fan is operating to fire hazard. So there's a reason we're waiting for that contact to close. When the pressure switch and the duct heater senses and proves airflow, only then will the heater be energized. So it's waiting for that. Prove airflow, then I'm going to engage my heater. We require a small 24-volt relay kit at the heat pump indoor unit and a standard system controller. The system is then wired in as first stage heat pump, second stage electric heat. There's many manufacturers of duct heaters with options of either on-off heaters or ones with modulating capability for increased efficiency. Check with the manufacturer first to ensure compatibility. So if you're dealing with a Mitsubishi system, check with someone from Mitsubishi to ensure compatibility with that inline duct heater. Most of them are going to work. This is a great application if you're utilizing a horizontal ducted system. It's pretty seamless as well. It's not that hard to do. Since it is a third-party product, it doesn't integrate as seamlessly as that electric heat kit. However, it's very, very easy to do just by doing what we said there. It's not that complicated when it comes to that inline electric duct heater. And these can supplement then the BTU loss that you need. Controlling supplemental heat with ducted indoor units is pretty easy. So what about ductless applications? How do we actually control that other than making someone go down to the floor and just manually turn on their electric baseboard when it gets too cold? For electric baseboard, fireplaces, all the different electric options we looked at, it can be as simple as setting the electric heat source thermostat to a lower temperature below the heat pump system set point. Say I set the electric baseboard to 60 degrees, my heat pump set point is 65, or I'm setting the I set the electric baseboard heat to 60 or say 65 degrees. I keep my heat pump setting set at 72. If I drop to 65, then you know that backup electric baseboard is just going to kick on because you set the temperature to that. It's as simple as that. So it'll only engage if the space temperature drops to this temp. You can do that. That's a simple application. However, that's okay if you're leaving it as just an emergency backup type thing. That may not be necessarily a good comfort strategy from a controls application to actually engage that backup heat. You can also utilize the controls strategy as this slide represents. In this instance, you would use a thermostat interface plugged into the indoor unit. A third-party thermostat would then be wired from the electric resistance heat source to the thermostat interface. From the thermostat, W1 would control the heat pump as first stage, and W2 would control the backup heat source as second stage. Thermostat interface is proprietary. Keep in mind that it's to Mitsubishi Electric, so other heat pump manufacturers may or may not have this capability. I can't speak to that. I can just speak to what Mitsubishi Electric can do. It's as simple as utilizing a third-party thermostat and our thermostat interface, and wiring in that backup heat source to W2 with the thermostat. So essentially you have first stage heat pump, second stage backup electric heat source. So it's very, very easy to integrate that. We have some different methods we'll look at as well, but this is about as simplistic as it gets. The same control strategy utilizing the thermostat interface can be used for a gas boiler hydronic coil and fully ducted air handler system like we looked at earlier. Here, the thermostat interface will be paired with a third-party two-stage heat thermostat. W1 of the thermostat will control first stage heat at the outdoor heat pump, while W2 would control a normally open 24-volt relay that goes to the boiler pump control to bring the circulator pump and boiler on as second stage heat. This is very simple. It's a cost-effective way of integrating a dual fuel heating strategy. It's not, once again, it's very, very simple. This is how that contractor I said in Southern Indiana is utilizing this. It's very easy. Once again, it's utilizing that thermostat interface and just wiring up appropriately to where now that hot water coil is coming on as your second stage of heat. There's a final method that we'll look at next, which can tie all of a home's HVAC systems together for centralized app-based control. This is a fully integrated control strategy. So you think, okay, how do I do all of these things? How can I do it and operate everything in this house from one platform, from one standpoint? This is a fully integrated control strategy. There's numerous methods available to tie in multiple pieces of equipment to one control's front end. So think of home and building management systems such as BACnet, Modbus, Savant, etc. You can tie those in, they work utilizing our third-party thermostat interface and third-party controls. A home's entire HVAC system can be managed via a single platform like a BACnet, Modbus, things of that sort. So we can do that with that third-party thermostat interface. This slide depicts a fully integrated control strategy utilizing Mitsubishi Electric's Kumo Cloud and Kumo Station platform as the front end for a home's HVAC system. Via this method, you can tie in your heat pump system, supplemental heat of any source, so whether that's a furnace, boiler, electric baseboard, any source, humidifier, dehumidifier, and ERV to a central panel with app-based control. Through the app, you can dictate when supplemental heat will be engaged via outdoor temperature sensors. You can control humidification and dehumidification based on relative humidity levels and manage the home's ventilation system all through your smartphone or tablet. App-based solutions like this are not only making it easier to integrate multiple systems, but they're also saving homeowners significant amounts of money on heating bills by optimizing the operation of multiple heating sources. There are utilities in the Northeast that offer rebates on such control strategies due to the amount of fuel oil that's being saved when air source heat pumps are enabled to operate when most efficient. Kumo Cloud and Kumo Station, once again, are proprietary to Mitsubishi Electric, so other heat pump manufacturers may not have this capability. I know I work with Build Equinox. We had Ty start this off here. They have the ability to let the serve take over our system as well too. And there's some testing he's doing right now, and he's talking about that 1-ton horizontal ducted unit being installed. So they have the ability to take over our system as well. There are a lot of fully integrated control strategies out there. If you have questions on whether something is gonna be compatible with a system like a BACnet or a Modbus or Savant or other different home automation system and building management systems, please reach out to us, reach out to your Mitsubishi contact, reach out to your HVAC distributor or contractor. We can let you know if it's going to be capable of doing it or not. We have the ability, as you can see from this slide, to take over the whole home. What I primarily like to use this application for is the left-hand side of this slide. This Kumo Station specifically is a great way to integrate supplemental heat. Just look at that box in the middle and think of it as a relay box, right? It's going to tell that system when to turn on that backup heat and when to turn that backup heat off. You're going to optimize it based off of outdoor air temperature. We want to utilize that air source heat pump as much as we possibly can. Let's get that efficiency out of it. I want to wring every bit of COP. I want to wring every bit of efficiency out of that air source heat pump before I need to integrate electric backup heat, specifically electric, because electric resistance, as we all know, 100% efficient, just costs a boatload to operate, right? So if electric backup, electric resistance is our backup source, I want to mitigate that and limit the usage of that as much as possible, completely if I can. But if I'm in a climate that absolutely needs it, let's make sure we get all of our efficiency out of that air source heat pump before we have to engage that electric resistance. If I have a gas backup, let's look at what can I do? Where is my balance point? Where is the most efficient temperature to turn off that air source heat pump and turn on that gas powered system? So if I have a boiler, if I have a furnace, I don't want to turn that on at 40 degrees. I'm still getting great efficiencies out of my air source heat pump. What is that temperature? We need to look at balance point. We need to look at economical as well as a thermal balance point. Where does this make the most sense to integrate that? And then set that outdoor sensor to only turn that backup heat source on at that temperature. So let's get the most efficiency out of this as we can. That's why I have areas of the country like the Northeast that are giving big rebates on a system like this, because look at what they're using, utilizing fuel oil a lot out there. It's very expensive. Natural gas here in the Midwest, you know, we're in the benefit of cheap fuel costs, but in the Northeast with fuel oil, it's very expensive. So they want to mitigate that as much as possible. By utilizing a control strategy like this, it makes it seamless for the homeowner. So not only can it save a lot of energy, it can make it a lot more comfortable as well too. In summary, so we banged through that pretty easy. Cold climate ducted heat pumps can provide exceptional heating performance in cold climates. They maintain high heating capacities even in sub-zero temperatures, providing year-round comfort. We looked at those cold climate heat pump charts. That is consistent with these cold climate heat pump systems. It's high capacity at deep negative temperatures. So a lot of times we think, oh, I need backup in Indianapolis. Well, maybe you don't. Let's look at your design temp. Let's look at your heating load. Maybe you don't need backup heat. Maybe the cold climate heat pump can act on its own. Ducted heat pump systems include an outdoor condensing coil, an indoor ducted unit, refrigerant piping, and a controller. Multi-zone systems can have a variety of indoor units, ducted or ductless, connected to a single outdoor unit. So just remember those applications that we looked at with them. Depending on your fuel type, application, and climate, backup or supplemental heating may be desired or required, right? A lot of it may be desired. Like I said, if I'm putting in a fully ducted air handler, I'm going to put in that heat kit just as a desire, right? As peace of mind. It also may be required. If you're in Minnesota, if you're in northern Wisconsin, you're going to need backup or supplemental heat on an air source heat pump. There are various types of supplemental heat sources, both gas and electric, to fit any application. A good control strategy is very important when integrating supplemental heat with an air source heat pump. The right control strategy, as we went over, can save on heating costs and provide optimum comfort. The control strategy is not that complicated, especially when we talk to Mitsubishi equipment with the use of the thermostat interface and third-party controls, third-party thermostats. We can tie things in very, very easily. And the Kumo Cloud and the Kumo Station gives us tremendous control and the ability to incorporate that backup heat when we need to. Hopefully you learned some stuff today. Well, it wasn't all review the first half of this, but if we would have just dug into supplemental heat control and didn't talk about the stuff at the beginning, people that would be new to these would be a little bit lost. So I appreciate everyone's time here. And Brett, if we have any questions, now would be the time. Let's fire away if we have anything.
Yeah, we definitely got a lot of questions here. And as those questions are coming in, just real quick, we just want to make sure we go over some of the connections here to the green building and LEED programs for these types of systems. So typically you're going to fall into the energy and atmosphere category and indoor environmental quality or EQ category with these types of systems. So the first big one to look at is the energy and atmosphere prerequisite minimum energy performance. So there is, you're going to be working with your, ideally your HERS index rater if you're in the US, your 90.1 ASHRAE energy modeler if you're doing large scale buildings, and potentially another system outside of the country. To determine if you're meeting the Energy Star version 3 standard. So these systems are going to get put into that to verify that you're on track for that standard. You have to make sure that if you're using dual fuel systems, such as the boilers, or any kind of backup heater, it's got to be input into that data. So the HERS raters should know this. They should be putting that information in there and making sure it's contributing to your overall energy model. You do need to make sure especially any new system that you're using getting installed has the AHRI certificates with it, so you can pick those up, make sure they have those labels on them. That is a requirement now for LEED certification and Energy Star certification. And the other thing to know is that it's easier to meet the heat load calculation sizing goals with these types of systems. And sometimes what we're finding, and especially tighter, well-built homes or multifamily, traditional gas forced air systems are typically oversized and can't even qualify for the LEED or Energy Star program. So this is one easier way to get to it, and it connects right within that first prereq of the minimum energy performance. All those things I mentioned, just all of that's mentioned in there. And then, you also have to commission these systems that Mike was referencing, but there's much less commissioning involved, especially when going ductless and when using Radiant, way less commissioning than you have to do with forced air systems. And so moving on to the next credit for LEED, the EA credit annual energy use. So when your HERS rater is giving you back that data, they're hopefully also giving you a better performing HERS index rating from choosing more energy efficient options, a higher tier SEER ratings, higher tier HPSF ratings, more energy efficient boiler systems if you're using those. So that's going to help you score more points in the energy category of LEED, which makes up about a fourth of the credits to get certified, quite frankly. So there's a lot to be done there. Now, moving on from energy and into environmental quality and indoor environmental quality, you have a combustion venting prerequisite. So again, if you are going with those gas boiler systems, obviously the newer, more efficient ones, no problem, they're sealed combustion. But if you're using older ones that are still in place, you have to ensure that it's sealed. Otherwise, it would need to be replaced and removed. You can't have unsealed combustion in a LEED home. The other good news is if you're going with the ductless systems, no ducts, you don't have to do any of the duct testing, which can lead to all sorts of problems for LEED. We see it all the time in the field. So no ducts, no problems, no testing. And then the last one, very interestingly, is these ductless systems are exempt from the MERV 8 requirement for filters in the EQ air filtering credit. And so you can use the one that it comes with, which I believe, and Mike, correct me if I'm wrong, but it's lower than MERV 8. However, and especially with the pandemic, we highly recommend higher levels, especially ones around 13 or so that can catch viral transmission issues. So or better off to do it. So even though you're allowed to get away with it, we don't recommend going lower than that. So those are some of the quick ways this fits in with the LEED program, and I do see a lot of questions coming in, so let's get to those questions. For those of you, go ahead, Mike.
No, that's it. Let's go. Go ahead.
Okay. Oh, for those of you who want to get to this, get your CEUs, check your inbox for the certificate, take the survey that pops up. For those of you watching this in the future, not right now, take that 80% quiz with an 80% passing rate anyway. You can find the quiz on our YouTube channel if you're taking it there by clicking the YouTube link. Then on the left, click the show more under the description. Then on the right, you will see a link to go find where to take that quiz. Huge thanks to all of our board of directors, our members, our volunteers, and our top tier sponsors, Mitsubishi Electric, Rheem, and Build Equinox. Check them out as well. So let's get into some of these questions, Mike, and let's go all the way back to the beginning just for the sake of one of our viewers. If you can just briefly again tell us the difference between ducted lines, the ducted lines, sort of the ductless systems with ducts, and the ductwork.
I think that was that picture of the ducted units, and I know you have the screen, so I can't go back to that. But it was showing the ducted indoor units, and then the dashed lines were ductwork. We're showing the ductwork, and then the solid lines from the ducted unit to the outdoor were the refrigerant lines. So you got the refrigerant line sets from the outdoor unit to the ducted indoor unit, and then the picture was showing the dashed lines were the ductwork. That's just the way that the picture was. There's probably some confusion on that. I just explained it. I
Muted myself here. Thank you. You had mentioned the dehumidification. I had some quick questions on that, but does that dehumidification work as well with the larger VRF systems?
Yes. So so everyone understands the VRF system. It's heating and cooling, right? So it's an air source heat pump. So I know we only talked about heating because we're in a cold climate. We're talking about supplemental heating, and you kind of gloss over the cooling benefits of the system, but it is an air conditioner, right? It's a heat pump, so it's doing all of your cooling. Our systems do a really good job at dehumidification. Is it a dehumidifier? No, it's not a dehumidifier by any means, but an air conditioner dehumidifies, and that's what this system is doing as well too. Where you get into, especially with high performance construction, right? We're green, so we talk about lower load things and higher performance construction. I actually recommend supplemental dehumidification or a system like the CERV that also does supplemental dehumidification when you get into shoulder season applications or low loads where you may have a latent cooling need and not a sensible cooling need. So our systems are air conditioners, right? So it's only going to run if there's a call for cooling. It's not going to dehumidify when there's no call for cooling. So if you get a day where you have a low load, but you still need a dehumidifier, that's where a supplemental. Yes, they do dehumidify. I glossed over the cooling when we're talking about these.
Okay, and I know, so I know up in our climate, we have a tendency to forget about HRVs, and your little slide there used ERVs. I know typically most people use them interchangeably. So someone just wanted to make sure that sort of joint combination interconnectivity could also work with an HRV.
Absolutely. Yeah. Absolutely. Same thing.
It
just depends on the climate, where you're at, and which one you want to use.
Right. Yeah. What are the differences between low ambient temp heat pumps versus standard regarding sizing, efficiency, electrical capacity? I mean, can you briefly discuss that?
Break it down as simple as possible for a standard heat pump versus both VRF, right? We're talking VRF systems, but a standard heat pump versus a cold climate system. The real difference is in the compressor, right? That's the real difference in the compressors. It's compressor heating output, its ability to continue to remove heat without overheating from outside, from overheating, and when it's too cold, trying to remove air too much. So you have a much more efficient compressor. So the efficiency ratings on a cold climate heat pump are generally much higher than a standard heat pump, just because they have, and this relates to not only heating but cooling as well too. Your SEER ratings on those systems are generally higher than your standard heat pump system. So you're getting higher, not only heating efficiencies, but cooling efficiencies as well. You're going to draw more energy when you're operating a heat pump at -5 versus 40, right? Because you're working harder to remove the heat from the air outside. So while COPs may be, let's just say, a COP of 4 at 47, that COP is going to go down as it gets colder outside, but it's natural because it's working harder, right? It's not like a furnace that is always inside in conditioned space and it's always operating at X efficiency. The heat and efficiency is going to be directly tied to the outdoor air temperature. So while it goes down, it's still always going to be much more efficient than electric resistance heat. Always
Right.
much more efficient than electric resistance heat.
Well, let's keep this efficiency conversation going. The question is, for Mitsubishi ductless mini splits, is there a preferred control setting that tends to improve efficiency during cold weather periods? I believe the entity Stephen Winter Associates found that operating some ductless mini splits on high fan setting improved efficiency compared to the auto fan setting during cold weather periods.
It's a lot of it's going to do with there really isn't, but a lot of it is going to keep the fan on. That's a key in heating is constant fan, because what that's going to help with is that stratification of air, right? So moving that air around continuously, especially in heating, is definitely going to help with efficiency, because you're not going to have that compressor having to ramp up to heat space temp and ramp down and up and down. Your highest efficiency is when you're cruising. So it depends on the application. If in one instance, if this home says, if I keep this indoor unit operating at high fan speed, well, maybe that's because it is keeping that controller, wherever you're sensing temperature from, satisfied longer. So you're not cycling on and off as much. In a small room, high heat or high fan speed setting may not be appropriate. I'm sitting in an office now that's fairly small. That low fan speed setting might actually be more efficient because of the space that I'm in. So it's really going to tie, a fan speed setting is going to tie back to the application, but keep constant fan on, especially in mode. We want to keep that constant fan, and that's going to help from an efficiency setting for sure.
Great. When integrating backup electric resistance baseboard, what thermostat is recommended? So the comment is, typically the baseboard will need a line voltage thermostat, but most thermostats connecting to the third-party relay are using low voltage. Do you have a recommended thermostat for this application? The one that you had shown, they had a couple concerns about that one. So
yeah, I threw. Everyone knows what the Nest picture looks like. That's
right.
Right. So it means nothing related to that at all. That was just a picture. I do not have a preferred application to tie in electric baseboard. As long as it will work appropriately, that's all that matters. You just want to make sure and check and see what that requires from a thermostat for that, and if we can tie that into a third-party thermostat, or if we can tie that into that Kumo station like we looked at. But I do not have a preferred. It's got to be two-stage controller. That's what's important. If a single-stage controller won't work, so it has to be a two-stage controller in order to tie in any sort of supplemental heating to that. Realistically, honestly, when electric baseboard and I speak to applications that I've seen, right? It could be different in other parts of the country and in other different areas, but when electric baseboard is being utilized, it's being utilized as an emergency backup application. Right. And in that instance, a lot of times you're using the little controller or the little thermostat that comes on the baseboard heater. Turn it off, turn it on in an emergency scenario. Or if you're going to be gone, like I said, you turn it on and set it at a very low setting, whether that's 60 degrees or 55 degrees, whatever it is, just so that it will turn on in an emergency standpoint. Usually electric baseboard is not supplemental. While we can engage that, the more common method is just stick it as an emergency backup. It's there if I absolutely need it because something happened to my heat pump.
Sure. So a lot of backups we're seeing now happening in the market are really that traditional gas forced air system where the air source heat pump operates down to a certain temperature and then the gas kind of picks up from there through the rest of the year. Can you talk to us a little bit about that kind of application and if there's anything available for that?
Yeah, currently, right now, Mitsubishi does not have that application. And when I say currently right now, I mean literally currently right now, because it's something we've been working on for a very long time. The key with what we're going to have, and from what I can at least speak to, because it's a constant evolving thing, but hopefully we're going to see that coming with under a year, hopefully. hopefully end of this year, early next year, is going to be universal, meaning it will work on any manufacturer's furnace, and we will have single zone, multi-zone capability, cold climate heat pump, not cold climate heat pump, many different applications, but it's really adding in a traditional A coil, as we call it, our A coil product, because it's really a traditional A coil that will be able to be universal to any ECM motor driven furnace that we can then engage. And then we have them out in our field for testing in various applications right now, just trying to hone everything in, mainly from a control standpoint, because we want to be able to not only have this, but then give you the ultimate control solution as well. So that, do you want to be able to incorporate the furnace to kick on at an economic balance point? You want to do it off of efficiency, or do you want to do it off of thermal or comfort balance point? How do you want to do it? We want you to be able to engage that appropriately for each home. Also, the key that is driven out is we want to make it universal. So we want to be able to tie that into any manufacturer. So we look at retrofitting applications. We talk about this as a bridge product. This is what we need. This is our bridge product to electrification. We know that. So that if I have X manufacturer furnace in my house, I can put this product right on that furnace as long as it meets the ECM motor requirements that you would need on that. So that is coming. And when I say single zone or multi-zone, that means you can have that as a single outdoor unit connected directly just to that A coil product on the furnace, or you could have a multi-zone where now I could take care of that master bedroom with a ductless indoor unit as well, and now have control over the whole house on that system. So it's getting the best of both worlds. The key is utilizing our cold climate heat pump technology. That's the big key to this thing that's not out there now, is the ability to actually not just put dual fuel systems have been around forever. It's not new. I was a contractor, and when I worked for a contractor, I installed dual fuel heat pump systems. It wasn't new. The problem was you were setting balance points at like 37 degrees.
Mm-hmm.
Well, you're spending so much, you're not really getting the most out of that heat pump. So by incorporating the cold climate heat pump technology, which is going to be the big key factors, you're going to be able to take that balance point down to say 0 or 5, depending on what you want to accomplish, to really limit that natural gas or propane, that fossil fuel usage in general. Let that heat pump take the brunt of the heating season.
Sure. Great. Thanks.
It's coming. I know Brett's been waiting for it. We're talking about it for a while.
Right. Stay tuned. So this question, I'm glad someone brought this up. I'm technically not allowed to talk about it, but it is something that's exciting to me because the LEED v4.1 program for single family has not been officially adopted yet. But within it, there is credits for decibel readings, dBA. There's a great app on your phone to get dBA ratings. And so a lot of your systems come with dBA ratings. LEED requires you, if you're doing the v4.1 non-balloted credit, to get EQ, environmental quality points, for having quiet living spaces and kitchen spaces. So can you talk to us just real quickly a little bit about your quiet ratings? In particular, this person's question, they were actually more concerned about the outdoor unit sound, not something required to test for LEED, but could be important if you're in according to them, a very adjacent lot. And so could you just talk to us a little bit about some of your sound ratings, both inside and outside?
Absolutely. When we say, and this is one thing that I don't think we tout enough, when we say our units are quiet, it's not a joke. It's as serious as can possibly be. Our indoor units are so exceptionally quiet. Not only the ducted, but the ductless as well, that when we say quiet as a whisper, it's quiet as a whisper, or quieter than a whisper. It's not just a statement. I'm looking this up for the DB, the outdoor unit, but it's a true statement. So we even show extremely low decibel ratings on our ductless units, which I'm looking at. Just drawing this out. Here's just a wall mount unit. An indoor dB rating on just this 9,000 BTU can go as low as 19 decibels. So as low as 19 decibels when you're on it. Yes, is it a little louder when you're going cranking full high fan speed? Yes, it is, but you're talking maybe 30. at that point, so it's not like it's extremely loud at all from any case. So indoor units are very quiet. Keep in mind when ducted units are measured from a dB rating too, that is at the unit. So think now that if I have a ducted unit here, but I'm 20 feet away on where my airflow is coming off, I'm taking a dB rating at that register, it's going to be much less. Outdoor unit decibel ratings are extremely low as well. When I say we tout how quiet our units are, I don't think we speak to enough of how quiet the outdoor units are. So you're talking maybe that outdoor unit going at full capacity have a dB rating of say 48 or so around that end. So it's still quiet, much quieter than a traditional air conditioner that you're going to have outside of your house. Where this attests to a lot is we do a lot around Chicago. It's the zero lot line type applications. Our equipment fits great because it's only about a foot deep. So they fit in these really tight lot lines. And if I say 48 dBs, that's running. That's really running. But most of the time we're not. We're modulating down. We're running at a very deep capacity that fans barely even running. There's applications where we've had homeowners complain of, I thought this unit was supposed to be running and I'm outside, I'm not seeing anything. The fan's moving super slow. Like, is this thing actually running? It's not running. It should be running. Very, very, very quiet. When our unit kicks on, a lot of times you can't even hear that compressor at all. You put your ear to it, you might be able to hear that compressor. So it is extremely, extremely quiet. I'm not just saying that because I work for Mitsubishi.
And one of you on the call was asking me who has that app. So I don't know if you can see that. It's the National Association or National Institute for Occupational Safety and Health. And, you know, we use this thing in the field for ratings. So you can see here I am being very loud and shouting and blowing your ears off right now. So I apologize for that. I guess it's a good thing to talk loud so you can hear me. So you guys can check that out. And hopefully we're going to have those folks on for a session this fall to talk about sound quality, very important these days. So the other question, getting into training, you've got training programs for contractors. Can you just briefly talk a little bit about that if people want to get trained or they want to get their contractors trained?
Yes, absolutely. So we have training centers, Mitsubishi owned and operated training centers, which I'm sitting on right now. This is in Schaumburg, Illinois, and we have them throughout the country. Here in the Midwest, we have one in Schaumburg as well as down in the Cincinnati area of Ohio. But we also, our distributor partners throughout the Midwest and throughout the country also have training centers. So we put on training here at our training centers as well as at our distribution partners. So we have trainers that do training here. We have distribution partners that do their training as well. So just reach out to me or reach out to Mitsubishi Electric. You can go to our website's MitsubishiComfort.com. You can find contractors on there. Reach out to anyone that you know at Mitsubishi or myself, and we can connect you with the appropriate distributor partner in your area. Because if we're not doing specific training, like we don't have a Mitsubishi authorized training center in Michigan, but our distributor partners would have the ability to put on training there. So this is owned and operated by us, but we do training as well as our distributors. So not only service and installation, but sales related, application, equipment selection, product overview stuff. We also can do things virtually, which we've all gotten kind of used to doing over the last few months.
Yeah.
Obviously, service and install is hands-on, but application and other things can be done virtually as
well. So a question that came in here, just real quick before we wrap up, related to the, you know, I guess they're asking either for a chart or maybe a program or some kind of help to allow them to figure out the optimum balance point to move to backup?
Okay. I don't have anything personally. If anyone does, please let me know. Right. I know that there are online tools out there. It's just heat pump balance point tools. It's all about your temperature. So you got to think your climate. So it's going to look at your climate. It's going to look at your indoor temperature. It's going to look at your outdoor temperature. It's going to look at your utility costs. So that's the key. There's not just a blanket. I don't have a blanket formula because it ties into utility costs and everything else related to that. So there are some online tools out there. I personally am sorry, I can't speak to one that I would recommend.
Okay. Yeah, great. And then there was a question earlier. I'm just going to quick address it before we wrap up. I don't see any more questions here coming in, and that was when mentioning using all electricity. Somebody was asking what about the grid makeup and the grid mix of what the energy is coming from. Of course, that is huge and very subjective to your local grid, very subjective to your country too. If you're calling in from another country. And where you're at. So check, your local grid makeup when it makes a lot of sense. One organization called the Rocky Mountain Institute has been doing a fantastic job of trying to determine when all electric systems become cost effective. Now they take, I think, a pretty neutral approach to it and pretty conservative approach to it. But they have some reports coming out on it. We've did one with them last year. We have recorded online that you can check it out about when it starts to become cost effective. Obviously, that information changes as grid makeup changes rapidly and more renewables come online. But that can be a huge point as to when it makes sense. And Mike, I don't know if you had anything to add to that, but
no, that's perfect. That's perfect.
Great. Yeah, so, well, everyone, I want to thank you all again for attending. Huge thanks to Mike Schaefer and Mitsubishi Electric for their time. Mike, where can people get more information and contact you if they want to learn more?
My email contact right on here. That's the best way. And then MitsubishiComfort.com. That is our consumer website. That is the best starting point for you. MitsubishiComfort.com.
Great. And public service announcement before we wrap up. We want to see you all in person someday. Again, we love doing webinars, but we hope to see you all. Hope to see Mike out for one of our Building Green and Beer events again. So we gotta do everything we can to social distance, wear our masks, and honestly, we gotta retrofit our buildings. We gotta get better ventilation, better filtration, and we're gonna beat this thing. And we're gonna see y'all in person 2021. And stay safe out there, everyone, and take care. Thank you so much.
Thank you, everybody.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.